Good afternoon, everyone, and welcome to the Q&A session 18 from the playlist of friction. The topic is the angle of repose, and this session is in continuation of the session number 16, in which we have studied about the angle of repose and the angle of friction. So, based on this topic, I have selected one question for this session, which is written here on this board, and the question is. In this figure, the angle of repose is 45 degree. We have to find the force of friction, net force, and the acceleration of this 5 kg block when theta is equal to 30 degree, 45 degree, and 60 degree. So, in the session number 16, we have learned that the angle of repose is the least angle of inclination of an inclined plane with the horizontal, such that any object placed over it is about to move. Means at the angle of repose, that object or the body will not move. It is on the verge of moving down along this inclined plane. That is, if I increase the angle of repose beyond the value of 45 degree, in this case, then this 5 kg block will start sliding down along this inclined plane. And in the session number 16, we have also learned that the tan of phi is the angle of repose, is equal to the tan of theta, where theta is the angle of friction, and this is equal to mu s, where mu s is the coefficient of static friction. So in this case, since phi is equal to 45 degree, so we can say that mu s, that is the coefficient of static friction, will be equal to 1, because phi is equal to 45. So tan 45 is equal to 1. So let us take the first case when the angle of inclination is equal to 30 degree. Now, as per the definition of angle of repose, a body will move or slide down the inclined plane only when the angle of inclination is more than the angle of repose. So here, since angle of inclination is less than the angle of repose, therefore the body will not move down along this inclined plane, and so we can say that the net force on the body will be 0, because a body will not move only when the net force acting on it is 0. First thing, and the acceleration will also be equal to 0. Now, the third point is, or the third thing which we have to find is the force of friction. Now, we know that the force of static friction, its value ranges from 0 to mu s into n, where n is the normal reaction. That is, this is the body of 5 kg, so its weight will be acting vertically downward, which is equal to 5 into 10, because g is to be taken as 10 meter per second square. So mg will be equal to 50 Newton, and here I am just resolving this weight into two components. One component is along this inclined plane, and the other one is perpendicular to this inclined plane. So the component which is perpendicular to the inclined plane will be equal to 50 cos theta, and the component which will be parallel to the inclined plane in the direction as indicated by this arrow will be equal to 50 sin theta. And the normal reaction will be acting in the upward direction perpendicular to the inclined plane. So the force of static friction, the value of the force of static friction, it varies from 0 to mu s into n. Here mu s into n is the maximum value of static friction. So now this value is variable, that is, this value is totally dependent on the magnitude of the applied force. If the applied force increases, this value will also increase, but the maximum value of this limiting friction, or the maximum value of the maximum value of the static friction or the limiting friction will be equal to mu s into n. So in the case of theta, which is equal to 30 degree, the force of friction will be equal to mu s into n, or mu s is equal to 1, and normal reaction. So in the case of theta being equal to 30 degree, the normal reaction will be equal to 50 cos 30. 50 into cos 30, and this is equal to, now the value of this cos 30 is equal to root 3 by 2. So this is equal to 25 root 3 newtons. So the force of friction when theta is equal to 30 degree will be equal to 25 root 3 newtons. The net force will be 0 and the acceleration will be 0. Now let us come to the second case when theta is equal to 45 degree. So when the theta is equal to 45 degree, which is equal to the angle of repose. So at this angle, this block will not move down along the inclined plane. So if the block is not moving, then we can say that the net force will be equal to 0 and the acceleration will also be equal to 0. And now here in this case, the force of friction, or you can say the force of static friction, will be equal to mu s into n. Now mu s is equal to 1. The normal reaction in this case will be equal to 50 cos 45. So this will be equal to 1 into 50 cos 45. So this is equal to, cos 45 is equal to 1 upon root 2. So this is equal to 50 upon root 2 newtons. Or this can be also written as, if I multiply this numerator and the denominator by root 2, so I will be getting the value as 25 root 2 newtons. So in the second case, when theta is equal to 45 degree, the net force is equal to 0, the acceleration is also equal to 0, and the force of the friction will be equal to 25 root 2 newtons. Now we have to find the value of the net force and the acceleration and the force of friction when theta is equal to 60 degree. So now I will be writing the values of this force of friction and net force and the acceleration when theta was equal to 30 degree on the top of this board. So this is when theta was equal to 0, then net force was equal to 0, acceleration was also equal to 0, and the force of friction was equal to 25 root 3 newtons. In the last case, when theta is equal to 60 degree. So in this case, what will happen? Because the angle of inclination is more than the angle of repose, so this block will start moving down along the inclined plane. And so in this case, the net force will be equal to, when the block is moving down, then the force of friction will act in the upward direction, say Fs, because the force of friction opposes the relative motion. So the force of friction will act in the direction as indicated by this arrow, that is, it will be acting in the upward direction, and mg, this 50 sin theta, this will be equal to 50 sin 60 now. So this is the component of this weight which will be acting down the inclined plane, and this block will move down the inclined plane when mg, or you can say 50 sin 60, is more than Fs. So the net force will be equal to 15 sin 60 minus Fs. And here the force of static friction will be equal to mu s into n. So the normal reaction here in this case will be equal to 50 cos 60. So 50 sin 60 is equal to root 3 by 2 minus fs. Now fs is equal to mu s into n, mu s is equal to 1. Normal reaction is equal to 50 cos 60. This is equal to 50. Now cos 60 is equal to 1 by 2. So this is equal to 25 root 3 minus 25. So this will be equal to 25 root 3 minus 1 newtons. So this is the net force which will be acting on this block, and because of this net force there will be an n acceleration also. So the acceleration will be equal to, acceleration is equal to force upon mass. So this is the net force. So 25 root 3 minus 1 divided by 5. 5 is the mass of this block, and so the acceleration will be equal to 5 root 3 minus 1 meter per second square. So the net force is calculated. We have also calculated the acceleration. Now we have to calculate the force of friction. Now the force of friction, Fs, will be equal to mu s into n. So mu s is equal to 1, and the normal reaction is equal to 50 cos 60. So this will be equal to 50 cos 60, and the value of cos 60 is equal to 1 by 2. So this will be equal to 25 newtons. So the force of friction will be equal to 25 newtons, and it will be acting in the upward direction as indicated by this arrow, and this will be equal to 25 newtons when theta is equal to 60 degree, and the net force will be equal to 25. This is the value of the net force, that is equal to 25 in bracket root 3 minus 1 newtons, and the acceleration of this block when theta is equal to 60 degree will be equal to 5 in bracket root 3 minus 1 meter per second square. So thank you very much for joining this session, and in the next session I will be coming up with a different topic from the same chapter of friction. So till then, have a nice day. Bye.